Hi guys, last lesson we finished the isomers and today we are going to talk about the properties and uses of alkane. In this part you will learn the main uses of the alkane and their properties. In the rest area they won't ask a lot of questions from that part, but also you have to know some more important information, important properties. First we have to know that carbon-hydrogen bonds, alkanes, are non-polar. As we know there are three types of bonds: non-polar, polar and ionic bonds. So it means that depends on the electronegative difference, we can have different type of bonding. But carbon hydrogen, as we know, they are close, so electronegative difference is very, very less. Because of that, it's a non-polar. So alkane molecules are non-polar compound. Because alkane consists of what? Carbon and hydrogen. So the only force attraction between the non-polar molecules are weak London dispersion. It's not important a lot, but you have to know also that one. The weak London dispersion force between the substance, non-polar substance, we have a London dispersion force, and depends on that one, depends on the number of the molecule. If it's large, it has a more force. If it's a less low molecule than small molecule, it has a low London dispersion force between the particle. There is the attraction is lower. So because of that, the physical state of the alkane can be different depends on their size. Their size and their states are related to each other. And what about physical state? Physical state is important because different number of carbon has a different state. You can easily determine the number of carbon by their physical state. For example, if you know the number of the carbon of alkane, you can say that it's gas, it's liquid, or it is solid. Firstly, you can continue. The alkane that have the lowest mass, those with 1 to 4 carbon, these are gases. It means from 1 carbon to 4 carbon containing alkane, these are gases. If your gas, for example, more than 1 to, for example, 4 to, for example, 10, it has a large, we can call them liquid. Carbon 5 to 10, we can call them, these are liquid. If the alkane has very, very high mass, it means that from 10 to goes to 50 like that, we can call them, these are the solid. It's very, very important. Between 1 to 40 gas, 5 to 10 is a liquid, 10 to 50 or goes like that, it's a solid. Also, very important, natural gas means the mixture of the gas which contains the carbon 1 to carbon 14 substance, alkane called, is a natural gas. Natural gas consists of, it means that methane, ethane, propane and butane. These 4 gases combined, they form a natural gas. And boiling point is other property, very, very important, because the boiling point determines and to separate the alkanes. We can easily separate the alkanes by using their boiling points. So let me continue that one. Yes, boiling points, important. Every alkane has a different boiling point because of the number of the carbon. The boiling point of alkane also increases with the molecular weight. It means that the boiling point increase the number of carbon also increase. It means that they are directly proportional. Number of carbon and boiling point are directly proportional. If they have a more high amount of carbon containing alkane, it is a high boiling point. As I told you, London dispersion force is also important, but you have to know that one. Boiling point and this attraction between the particles are related. Because of that, if you have a high attraction, it has a high boiling point. Because of that, if number of the carbon increase, there will be a high attraction. Because of the high attraction, there will be a high energy. It means that it has a high boiling point. And this property means boiling point, used in the separation petroleum, the major source of alkanes. It means that very, very important because we can use the alkane, we can use the difference of the boiling point, we can separate them. As we know, with the petroleum, what petroleum means? Petroleum is a complex mixture of different hydrocarbons that varies greatly in a composition. In your composition petroleum, we have different types of different number of carbon atoms. They are mixing. But when they use the industry, they separate them and we can get benzene, we can get gasoline, we can get naphtha, we can get paraffin, we can get different types of, we can get, for example, gas, LPG, we can use this separation method by using the boiling point. Because it will be important, but petroleum is the mixture of these all the alkanes. So the hydrocarbons molecules in petroleum contain from 1 to 50 carbon. And that I told you, petroleum consists of the compound that contains the carbon from 1 to 50 carbon. And this range allows the separation petroleum into different portion of the, have a different boiling point range. It means that if you have a mixture that contains different number of carbon containing substance, you can easily separate them by using their boiling point. Because of that, if boiling point increase, the carbon of carbon increase. As you see, look at the chart, you can see that one. The boiling point increase because of the boiling point number of the carbon increases. So if you, for example, you have a petroleum, if you try to boil it, you can get firstly CH4 because the lowest boiling point. After you can separate the methane, you can get the ethane. After ethane, you can get the propane. After you can get the butane. It goes like that. You can separate them and you can get new substance. Benzene, gasoline, naphtha, LPG, for example, the gas that you use in the kitchen. You can separate them by using their boiling point. Also this one there, 1 to 4 carbon is a gas, 4 to 10 is a liquid, 5 to, for example, goes like that, it's a solid. Sorry about that. Let me continue, guys. Next topic is about the combustion, I think. Yes, combustion. Guys, as you know, what was combustion? Combustion means burning something with the oxygen. Also, we have a carbon and we have a hydrogen. They can easily burn because of that. Alkane has a combustion reaction. But alkane and the other hydrocarbons have a different property to burning. Because alkane are less reactive than other hydrocarbons of alkane and alkyne because there's a double bond, there's a triple bond. They're unsaturated and it's saturated. If it's saturated, it cannot easily burn with the carbon, so the stability of the alkane is bigger than alkene and alkyne. Because of that, they cannot easily burn. But they are used of fuel for engine. We can use for them benzene, the alkanes, but alkane make up large proportion of gases and the liquid fuels, but it's not enough only alkane. Because when you burn the alkane, it goes, for example, CH4 form 2O2, CO2 and 2 water energy. It gets energy. We can get energy, the cars work. But how the cars work, how can we use the benzene? There's the definition of the knocking. Knocking is the disturbance of the engine by incomplete burn of gasoline fuel because of presence of straight chain hydrocarbons. Straight chain hydrocarbons means that it's not easy to burn. Because of that, the engine cannot easily work because of that one. So you need different substance to produce more energy. So you can need anti-knock substance. What are these? So there must be anti-knock gasoline, we can call them isooctane, which consists of the branch hydrocarbons that ignitize spontaneous. It means that, guys, straight chain cannot easily burn, so you need branch, so branch can easily burn and it gives you more energy. Because of that, in your for example fuel, you need also more amount of branch chain hydrocarbons. The most important, the most common branch chain hydrocarbon is anti-knock gasoline is isooctane. Isooctane, the name of isooctane's name, and the chemical formula is 2,2,4-trimethyl pentane. Let me write here. Pentane, 1, 2, 3, 4, 5. It's not important to memorize, only try to understand. And 2,2,4-trimethyl, 2,2,4-trimethyl. And this is the CH3. There's no CH2, CH, CH3. We can call them, this is isooctane. isooctane, we use that one. Did you remember when you go to, for example, fuel station, you can ask them how many octane you say, mostly. The octane means that, yani how many percentage of isooctane that your gasoline, your fuel contains. Depends on the number of the octane, the amount of the octane, your benzene qualities can change. For example, 100 octane means you have 100%, you have a isooctane and 0% straight chain carbon. But if there's a zero octane hydrocarbon, zero octane benzene means it doesn't contain the isooctane. It has only heptane, means straight chain. It doesn't have any branch chain hydrocarbons. That I told you depends on the octane rate. We can say that the benzene has a high quality or low quality. Okay, so octane rating means fuel is a measure of its burning efficiency and its anti-knock properties. If you have a high octane, it has a high anti-knock property. It means it can easily burn. But if you have less amount of octane, it means less amount of isooctane compound and branch chain hydrocarbons. It is a low burning efficiency and is a low anti-knock property. Do you have any question about it? If you can ask me about why about it.